Let's consider divergence. Now, what is divergence? Your divergence is basically denoted with this symbol. So we have gradient dot your field given. This is how we represent divergence. So we can see that it still has that same similarity with gradients, but the only difference is the dot multiplied by your particular field given to you, or your particular what parameter given to you. That's the difference between your divergence and your gradient. Now take down the definition of divergence. So basically, the divergence of a field is the net outward flow of that field from a what? A point. Now, from our definition, what you can note down for the definition of a divergence is a what? A point. So you actually be given your points. Now, how do you now represent your point? What we use to represent our point is our what? Magnitude. So let's say we are given point 012. Let's say you are given a point 012. Now, what do? You simply represent your point with your magnitude. That is, you have your 0 to be what? X, Y, Z. Now, you can see that X, Y, Z, they are our magnitude, and those magnitude, they have what? Certain points attached to them. That's the difference between your gradient and your divergence. Now, what's the concept behind your divergence? The concept is very simple. Let's say we are given a field to be what? Fxi plus what? Fyj plus what? Fzk. Now, looking at our field, we can see that our field is a vector field. Why? Is because it's having what? Magnitude and what? Direction. Are we together? Now, what is now the divergence of our field, our vector field F? The divergence of our vector field F will simply be what? Partial I of what? Partial X plus partial J of what? Partial Y plus what? Partial K of partial Z. And this will be multiplied with our field given, which is what? Fxi plus what? Fyj plus what? Fzk. You can now see that they have the same concept with your gradient. Are we together? Now, what do? What we have here will be multiplied with what we have here. What we have here will also be multiplied with what we have here. And what we have here will also be multiplied with what we have here. Now, how do we interpret this? Remember, you can interpret this by saying what? We are differentiating your I component with respect to what? X. So what we have here will simply be what? If this is multiplying this parameter, which is fxi, this is simply telling you that we are differentiating this I parameter just with respect to what? X. That's the meaning. Let's go over to the next one. Partial j of partial y multiplied with this. Now, when they are multiplying, what you are doing is, this is your j component, right? Now, but on this j component, our interest is to differentiate with respect to what? Y. That is how we interpret this also. Are we together? Now, if you do that, you simply arrive at a certain value to be what? Xi dot I plus what? Yj dot what? J plus what? Zk dot k. Now, from our dot product concept, we know that when we have same parameters multiplying each other, that will give us what? A constant of what? 1. So what you have here will simply be what? 1. What you have here will simply be what? 1. And what you have here also will simply be what? 1. Such that when they multiply with your magnitude, you will now arrive at what? X plus Y plus what? Z. Now, what's the unique thing about divergence? The unique thing about divergence is you are basically using these points given to you to represent what? With your magnitude. And that's telling you that this will be what? 0 plus 1 plus what? 2. And that will give you what? 3. Now, this is the unique thing about divergence. You actually get a certain value for your field given, which is what? 3. Now, let's take some examples under divergence. Now, the first question we have here is, we are basically given to find the divergence. The first question here, question 1, we are asked to find the divergence of an electric field vector and we are given the electric field vector to be 4xy square of z I component plus what 10xyz of what j component plus what 5x square y square z square of what k component at point 1, 2, and what 10. At point 1, 2, and 10. So what you should first do is you simply take your points to be what x, y, z. That's the first thing you do. Now the next thing is to apply the concept of what divergence. Now what are we asked to find? We are basically asked to find the divergence of your field vector. That's what we are asked to find. The divergence of our field vector. Why is it a vector? Because it's having what? Both magnitude and direction. Are we together? Now, with further ado, let's go into the calculation for our divergence for electric field vector. Now, what we'll simply have there is partial I of what? Partial x plus partial j of what? Partial y plus what? Partial k of partial z. Now, what we have here we multiplied with our field vector, which is what? 4xy square zi plus what? 10x what? Y z of j plus what 5x square y square z square of what your k component. Now what you simply do is what we have here will be multiplied with what we have here, and I told you that for you to interpret it, you are simply interpreting this to be what we are multiplying partial I of partial x with what 4x y square z of I component, and we are differentiating what we have here, which is our I component, with respect to what x. That's the meaning. Now if you do that, you simply apply the same concept with what we have here, which is partial I of partial y multiplied by what 10. This is 10, so we have 10xyz of what our j component, and you have this also to be multiplied with what we have here. Now, what's the next thing you are doing? The next thing is to solve your partial I of what? Partial x. Now, solving that, this is simply telling you that on this angle, we are differentiating what? X. We are differentiating your I component, which is 4xy squared z, with respect to what? X. And if you do that, this will simply give you what? Remember, this is 4x. If you differentiate 4x, you have a constant of what? 4. And that will give you what? 4 here. And what are the other parameters added to your x? We are seeing what? Y square and what? Z. So here you simply have y square and what? Z. Now remember, you have I multiplied by I dot product concept, that will give you what? 1. So there's no need of putting it. Now the next one is plus. For your j component, we are differentiating with respect to what? Y. Differentiating with respect to y, we are seeing that we have 10xy here multiplied by what? Z, and that z is multiplied by your component given, which is what? J. So what do we do? If you differentiate y, you have what? 1. So what you have there will be what? 10x multiplied by 1 multiplied by what? Z, and that will still give you what? 10xz. J multiplied by j, dot product concept is 1. So there is no need of putting it. And let's go back to the next one. Let's go back to the next one, which is what? 5x square y square z square. Here, we are differentiating with respect to what? Z. Now, if you differentiate with respect to z, you simply have this to be what? 5x square y square multiplied by what? 2z. Are we together? Now, you have k multiplied by k. Dot product concept is what? 1. So, you are left with 5x square y square multiplied by 2z. Now, this can be multiplied with your 5 here because they are both constants, and that will give you what? 10x square y square of what? Z. So what you have here will be what? 10x square y square of z. If you were asked to get the gradient of the field vector, This is where you stop. This is where you stop. But in this case, we are asked to get what? The divergence of the field vector. Meaning we are replacing our magnitude with our what? Our given point, which is 1, 2, and 10. Now, doing that, you simply have this to be what? 4 into, what's your y? Your y here is 2, so you have 2 raised to the power of what? 2 multiplied by what? 10 plus 10. X is what? 1. So you have 1 multiplied by what? Z is 10 plus what? 10 multiplied by what? What's your X? 1, right? So you have 1 square. And what's your Y? Your Y is 2. So you have 2 square multiplied by what? 10. So what you simply do is you punch your calculator. What is now the divergence of our field vector? Now, from the value we are getting from our calculator, we'll simply have our divergence of our field vector will be equal to what? 600 and what? 60. So you've simply gotten the value for your field vector. That is how we find the divergence of vectors or what? Scalar.